Which of the following could be the correct action to perform on a solution with a pH of 2 in order to create a new solution with an H3O plus of 1.1 times 10 to the minus 4 molar? Okay, so we have a pH of 2, which is 1 times 10 to the negative 2. So we want to either dilute it or neutralize it. Yes? So addition of water would work. You don't want to add acid because that'll make it more concentrated. So that's like this one, this one, this one, and we're not there, so it's got to be B. Yeah? Brian? For number 20? 28. Yeah. Although if you're doing it in a multiple choice, you can be like Ka equals concentration of H plus squared over concentration of HA. Just like the acetic acid we did. And so if you're looking for what is the pH, you would have Ka, H plus squared is equal to Ka times HA. If you are familiar enough to do that without doing a rice table, you can do it quickly on the multiple choice. But yes, a rice table will get you there as well. Okay? Yeah. Yes. 31. Okay, so for this one, we have H3PO4, and we have dissociated 2 of the hydrogens, and we have 1 left on there. So it's successive ionization. So that's ionization number 1, number 2, and number 3. That means taking off 1 hydrogen and then taking off a second hydrogen and then taking off a third hydrogen. So what they're saying there is that the first ionization is H3O plus, or sorry, H3PO4 gives H plus plus H2PO4 minus, and our second ionization is H2PO4 minus in equilibrium with H plus and HPO4 minus. And this has a value of Ka1. That's the first dissociation. This has a value of Ka2. And if I were to write the third one where I took a hydrogen off of here, that would be Ka3. But I don't really want to do that because as my final product, that's kind of where I end. I only take off 2 of the hydrogens. Okay? Now, if I want to end up with my overall reaction, if I add these 2, I will get the overall reaction because the H2PO4 on the right will cancel with the H2PO4 on the left, and I'll end up with H3PO4 in equilibrium with 2H plus HPO4 minus, and that is the reaction that we had here. Yeah? Now, if we add 2 reactions together and we get an overall reaction, how do we use their K values to find the overall K? We multiply them. So that's going to be K is Ka1 times Ka2. Yeah? Good stuff. Yes? 33. Which of the following equilibria lie heavily to the right-hand side? Okay, and we are told that the order of the acids, so we have the acid strengths here. So Yeah, I was like, well, we have a strong acid here, so let's look for the one with the HCl on the, oh, hang on, the left-hand side, because that's going to push that to completion. Not just push it like to the right. You're not just going to favor the products, you're going to go all the way to products. Okay, because that is a strong acid. And this one here, this is also going to go all the way to products, or sorry, reactants. So if they'd asked you which lay most heavily to the left-hand side, that would be B, but they're looking for to the right-hand side, so that is C. Mm-hmm. Because it can. If we put a one-way arrow, it would be obvious. Yeah. Any other questions? Yes. 19 regular, yes. Which one of the statements about HNO3, which is strong, and HNO2, which is weak, is true? Conjugate bases are NO2 minus and NO3 minus. And if this is a strong acid and this is a weak acid, then its conjugate base will be stronger. Yeah. The weaker the acid, the stronger its conjugate base. And that means that since this one is stronger, this is going to be weaker, so it's going to be A. Is good? Justin and then Amy. Yeah. Yep. FRQ number 7. Yep. Okay. Did we not do this one already? Didn't we do that one? Or was it with my other block? I guess, I don't know. Okay, well, let's give it a try. I thought we did this. Are you sure we didn't do this? Okay, because yesterday, and I think it was this block, because I don't think block, whatever they are, had any questions. They were like, no, we don't have questions. They're always like that. No, I don't have questions. And for half of them, I think that's true, and they do well. And then the other half, I'm not quite sure. I'm like, you should be asking more questions, but whatever. We had the pH of 4.20, so that meant we could find, our concentration of hydrogen. Yes? Okay, by taking 10 to the negative pH. And that means that we knew the concentration of H3O plus is 6.31 times 10 to the minus 5. And these two have to be the same, yes? Yeah, because they both started at 0. They both went up by x. And so x in this case is 6.31 times 10 to the minus 5. I'm sorry, it's so messy and you can hardly read it. Yes? Doesn't matter. Just go with it. That's what the question says. It kind of bothered me too, but I just let it go because I don't need to know it to answer this question. Yeah. All right. Next up, Amy and then Jade. 24 regular? Indeed. Which of the following species is the weaker base in the equation? So what we need to do is we need to say, okay, we have our acid. we have our base, we have our base, and we have our acid. And I know that none of these are strong, and I know that H3O plus is the strongest acid. So this is going to be the stronger. So this is going to be the stronger. So this is going to be the weaker. And this is going to be the weaker, because the two weakers are always on the same side and the two strongers are always on the same side. So that would mean H2O is the weaker base. And actually H2O is the weakest base. So maybe I could have done that without going through all of that nonsense, but yeah. Jade. 29? Yes. pH, water has, at 25 degrees, has a pH of 7. And here is the equation for the dissociation. So at 80 degrees, so we have increased the temperature. So that means the system's going to shift to the right. But it's still water, so it cannot be basic and it cannot be acidic, because these two are still going to be equal to each other, because plus X and plus X, right? They're going to go up by the same amount, so they're going to be equal. And if they're equal, it's neutral, not acidic or basic. So it's either going to be C or D. And these went up, so the concentration of H went up, therefore the pH went down. So that would be C. Yes?
This isn't like on the
Yep.
for Arrhenius bases and like lots of other bases on like the definition, like these like species and substances. Like I don't remember like the specific one, which one was species and which one was substance.
Doesn't matter. You can use those terms interchangeably. Yeah. Yes? 54 for sure. Which of the following solutions will have the lowest electrical conductivity? So they're all the same concentration. Yes? We have a strong acid, we have a strong acid, we have a weak acid, and we have a salt, okay, an ionic compound. So this is going to give me H plus and I minus. This is going to give me Na plus and NO3 minus. So that's going to give me 2 molar ions. So far, so good. And this is also going to give me 2 molar ions, because I've got one of each. This guy is going to give me 2 molar ions, but then it also has produced HSO4 minus, which can undergo a little bit extra dissociation to produce H plus and SO4 2 minus. So you will get a slightly high, we wanted lowest electrical conductivity. That would be this one. Sorry, I was going for highest there, and then I reread the question. And yeah, the lowest one will be the weak acid, because most of it stays intact and very little dissociates. But if it did ask for highest, it would be this one, but not by a huge margin, okay? Because the second dissociation is not huge compared to the first. Mm-hmm. Yes?
I just saw like 50, so like are we responsible for going like what? Like this whole thing so like once?
I didn't put any of those in there, but anything that's sour, you can be like, oh, acid. Oh, I know tap water is neutral or close. Pop, acidic. So even if you didn't know, you could be like, oven cleaner. No. But I want you to think about this. Oven cleaner, it's a cleaner. Cleaners are usually slippery, and bases are slippery. Yes, you have to know the properties of acids and bases. Yes. 25? Yeah. A solution with a concentration of 8 OH minus, 1 times 10 to the negative 6. So that is bigger than 298 Kelvin is 25 degrees Celsius. This is bigger than 1 times 10 to the negative 7, so it's going to be basic, because 10 to the negative 7 is neutral, so it is basic. Hello, come on in.
We're here collecting donations for Remembrance Day. I'm sure the other group from yesterday has already told me what it's about, so I'm not gonna go through the whole lecture again. But any money you have, even $1 would be really appreciated.
I'll see if I have anything. I've been giving away money to people though, so I probably don't have anything appropriate. I do. Oh my God, I have some change. Okay. Oh, I got a toonie. That sounds appropriate. Yay. I was like, if all I have is a 50,
Any money is asked. Thank you. I donated on Wednesday and Thursday, so please bring everybody.
Yeah, I went to the bank and I took out some money, and you know how it like spits out 50s at you, and I'm like, oh, I should have. All right, 50. What am I going to do with a 50 anyway? So you can choose, but I was like, I don't know. I was in a hurry that day, and I was just kind of like, nah. Yeah, I don't know. Okay, where are we at now? Are we done? 17, explain the third option. For a P solution with a pOH of 10, concentration of H3O plus is 1 times 10 to the negative 10. Well, that's just wrong, isn't it? Yeah, the answer doesn't include 3, does it? No, because this would be a pH of 10, and the pOH would be, if that were the case, the pOH would be 4. Or if this were true, then this would be 1 times 10 to the negative 4. Yeah. So they can't both be true. Algo más? Anything else? Okay. Green book.
What page?
We are on page, just give me 1 second to grab this. We are on page 27. Please remind your partner, what were the 2 types of equations we were looking at yesterday?
Participation.
So we had the
Precipitation.
solubility, equilibrium, equation, 27. And we had the precipitation equation. What do we use a solubility equilibrium equation for?
For solids on the left-hand side?
KS, we use it for KSP, which is the solubility product constant. What do we use the precipitation equation for? We use it for a precipitation reaction. And we use it for titrations. Hang on a second.